Good evening, Chris here, Griffiths Eating. We're charged today with getting this Ideal Logic boiler working sweetly. Now, not a big fan of Ideal Logics for various reasons. They don't modulate low enough. The pump, you can't adjust the pump, it's just totally non-adjustable, and it doesn't pump low enough. We'll get into the reasons why that's a bad thing in a minute. But on this job, it's a full hit we've been doing. We've done a bathroom, nice big shower, the usual remote thing, turn that on, monsoon head, hand spray, toilet, basin, towel rail. We built this wall out to hide the 4-inch for there, so it's worked out quite nice, quite a nice little job. We've built all this in stud work and used the construction board. It's like a fiberglass reinforced insulation behind there, just so it's super waterproof. Tanked the lot, so it should never ever leak again. Done a proper job on that, and we're trying to do a proper job on the heating as well. So we bought, I was going to weather comp it, but then I thought I'll go for the Halo open therm controller. So it basically modulates the output of the boiler to suit the room temperature. Doesn't fit this boiler. It's a fairly modern Logic, but for some reason, I think it's pre-2019, the Halos don't fit, and you've got to get a special wall mounting brake. It should fit into here, it should be a plug and play, but it's a different interface there, so you need to get a separate interface, and just a bit of a nightmare. But we will get open therm controls running on this. We've also got pressure independent TRVs as well. I'll show you what they are. So at the moment we're only running 3 radiators on this system. We've got one radiator there, we've got a radiator there and a radiator there, so it's about 4 kilowatts of load on this system. And this is one of the reasons why I don't like the Ideal Logic. At 4 kilowatts of load, that boiler should be able to modulate nicely and run it, but because the minimum output on the Logic is something like 7 kilowatt, it's absolutely shit in the bed and cycling like crazy, trying to run 3 radiators. So the delta on the flow and return, because the pump speed is just too much for the system, it's like 1 or 2 DT, so it's fucking, the flow rate through the system must be massive. But once we get the other rads on the system, hopefully it should even out a bit, and with the open therm controls it should work a bit better. But yeah, Ideal Logics, they're not great. It's just modulating like crazy. It doesn't modulate low enough. Something like a Wiesmann V200 will modulate down to 1.8 kilowatts. Stick that on this system, and it would purr all day long. 1.8 kilowatts through it, no problem. Super adjustable pump. Yeah, basically, Ideal Logics are just a fucking bonfire in a box. Absolute shit. So to help us try and balance the system out, because building reg state, you should be balancing your systems. We've gone for a pressure independent TRV. Now, what pressure independent TRV is, and we've used the Danfoss RAS B2, what it do, it sets the flow limit through the radiator. So whatever the pump's doing, as long as there's enough head on the system or pressure in the system to supply the minimum load to the radiator, which if you map the pump properly, which you can't do on an Ideal Logic, you should always have enough to get the flow rate and the heat output from the radiator. But what can happen is when the other radiators on the system start to shut down, say we've got 7 rads, 5 shut down, all that extra flow has got to go somewhere, and usually it'll go through the last rad that's open. So what that valve does, it stops, it limits the flow through the radiator. So you'll only ever get, even if this is the only rad on the system, all these are shut down, the flow will never increase past a certain point on this radiator, so you'll never get that overshoot of temperature. So as ever with most things, plumbing and heating, you buy these fancy valves, game-changing valves that are going to revolutionise the heating industry. Nowhere in the instructions does it give you any clue of how to set it. Well, how you set it is you rotate, there's numbers, you probably see on there, there's numbers on there, and you align them with this, and those numbers correspond to something. Now, because I know how to do a flow calculation, I kind of figured out how to do it. On the back of the box it gives you this sliding chart. Super confusing. RAS C2, don't know what that relates to because this is a RAS B2. Yeah, don't know. So I've calculated the flow through this radiator, and how you calculate the flow through a radiator is kilowatts divided by delta T of 20 times 4.2, that comes to 84, so 1.7 over 84, and then you'll get your flow rate through the radiator in litres a second, and we need that in litres an hour, excuse me. So the flow rate through this radiator, I think, is about 70 litres an hour. So setting number 6. So the flow rate on that radiator will never go above 80 litres an hour. That's how they work. Whack the head on, and then that's balanced. That radiator is now balanced. Don't need to run around the system with thermometers. That's balanced. And also another thing you're going to have to do if you want a perfectly balanced system is you're going to have to size the radiators correctly. You're going to have to do a heat loss calculation on the building. Full, proper, long-handed heat loss calculation. None of this guessing. We need to employ a bit of science and engineering because we are heating engineers. So you need to go around, measure each room, measure each wall, measure each window, take into account the construction of each wall, cavity insulation, what's beneath, what's above, loft insulation, put it into a table, work it all out, get your full heat loss for the property, and bingo, you can then size your radiators.